Construct a Venn diagram representing the sets given by each of these set operations. So for the first problem, A intersect B union C. To get a handle on this, I want to take this Venn diagram we have written out and number each of the regions. So this first region here is 1, 2, 3, 4, 5, 6, 7, and then the outside is 8. This will just help get things organized. So if we look at this, A consists of regions 1, 2, 4, and 5, everything in the blue circle. So A we can write as 1, 2, 4, 5. We're going to intersect this with, well, now B union C. B is the set consisting of everything in the red circle. That's 2, 3, 5, and 6. And we're going to union that with C. C consists of everything in the green circle, which is 4, 5, 6, and 7. So we're going to deal with what's in the parentheses first. So if we union these two sets together, we take everything that is in either of the two sets. So we're going to need 3, we're going to need 2, 3, 4, 5, 6, and 7. That's the union of those two together. And then we'll just bring down the rest of the expression we've been building up. So we'll carry down the intersection and the 1, 2, 4, and 5. Now to do the intersection, we want to see what these two sets have in common. And I see that 1 is in the first set, but it's not in the second set. 2 is in the first set, it's also in the second. So we know 2 will be in the intersection. 4 is in the first set, and it's also in the second set. So 4 is in the intersection. 5 is in the first set, 5 is in the second set, so it's also in the intersection. Any other element isn't in A. Those are the only choices that we could have in A. So those are the only possibilities we have for the intersection. So 2, 4, and 5 are the regions that are in A intersect B union C. So 2, 4, and 5 would be everything in region 2, everything in region 5, everything in region 4. So it would be that part of our Venn diagram. Let's move on to question 2. B union A subtract C. So just like before, I'm going to translate each of these into numbered regions. So B, that contains regions 2, 3, 5, and 6. And then we have the union. And then we have A, that's the set 1, 2, 4, and 5. And we're going to subtract from that set C, which is regions 4, 5, 6, and 7. Just like before, we want to take care of what's in the parentheses first. So in those parentheses, we're going to start out with those that are in the first set. So we have 1. 1 is not getting taken out because it isn't in the right-hand set. So we get to keep it in the subtraction. 2 is in the first set, but it is not in the second set. So we get to keep it. 4 is in the first set, but it's being subtracted out. So that's gone. 5 is in the first set, but it's being subtracted out, so that's gone. So the only thing left after this subtraction is regions 1 and 2. Now we'll copy down the rest of the problem, 2, 3, 5, and 6. Now to union these two together, we take everything that is in either one of the two sets. So I see that we have a 1 in one of the sets. We have a 2 in one of the sets. We have a 3, 5, and 6. So 1, 2, 3, 5, 6. We've simplified all the set operations, so we know this will give us the Venn diagram that we're looking for. So we have region 1, that's everything outside here. We have region 2, that's everything up here on top. Region 3, region 5, and region 6. So that's what our Venn diagram looks like for number 2. Finally, the third problem. A intersect B complement, subtract C complement. So first we'll start by translating these into regions. So A, that as we saw before, contains regions 1, 2, 4, and 5. We copy down the intersection sign, and then set B that contains regions 2, 3, 5, and 6. Bring down the complement sign, bring down the subtraction, and then set C, that contains regions 4, 5, 6, and 7. And we bring down the complement on that also. So we want to take care of what's in the parentheses first. So if we intersect these two sets together, we're going to look for what's common to both. 1 is in the first set, but it's not in the second set. So 1 will not be in the intersection. 2 is in the first and in the second, so we keep 2 in the intersection. 4 is in the first, but it's not in the second set, so we're going to throw that out. 5 is in the first set and in the second set, so we're going to keep the 5. And we bring down that complement, bring down the subtraction, and bring down our second set. 4, 5, 6, 7, complement. And now we need to complement these two sets. So the first one, the complement of regions 2 and 5 is everything except regions 2 and 5. So that will give us region 1, 3, 4, 6, 7, 8. So we've complemented, which all of our regions were numbered 1 through 8. So we count everything from 1 through 8 except 2 and 5. That leaves us with these 6 pieces. Subtract, now we complement 4, 5, 6, and 7. And this will give us everything except 4, 5, 6, and 7. So we keep 1, 2, 3, and 8. That's everything except 4, 5, 6, and 7. And then finally, to subtract these two, we're going to start out with our first set, and we're going to subtract those elements in common to both. So 1 is in the first set, but we're going to subtract it out because it's also in the second set. 3 is in our first set, but we'll subtract it out because it's also in the second set. 4 is in the first set, and we're not subtracting it out because it is not in the second set, so we're going to keep the 4. 6 is in our first set, and it's not getting subtracted out, so we keep it. 7 is in the first set, and we don't subtract it out because it's not in the second. 8 is in the first set, but it's being subtracted out because it's also in the second. So 8 is gone. That leaves us with just 4, 6, and 7. So now we can go back to our diagram and we can shade in regions 4, 6, and 7. So we're going to shade in region 4, region 6, and region 7. And that gives us the Venn diagram for the last picture.